Okay, so today we're going to learn about different angle pair relationships. So the first angle pair relationships are, the first one is complementary, and these are going to be two angles whose measures have the sum of 90 degrees. The second angle pair relationship are supplementary angles, and those are two angles whose measures have a sum of 180. And then the last angle relationship are adjacent angles. And those are two angles that share a common vertex inside, but have no common interior points. So if you think about the word adjacent and what it means, adjacent means next to. So they're going to be two angles that are next to each other if I talk about adjacent angles. Now, I have some little tricks to help you remember to keep track which ones are supplementary and which ones are complementary. Little tricks that work for me, and you may have other ways to remember it, but I think about saying the alphabet, the ABCs. And I think that when I say A, B, C, D, and I say the alphabet song, I think C becomes before S, and I think 90 is a smaller number than 180, so that's how I can associate those. Another thing that I might do is I take the C in complementary, and I can put a line down there, and that looks like a 9 to me. Or I could take the S and put a line this way, and it turns it into an 8. Whatever little tricks are going to help you to remember that complementary is 90 and supplementary is 180, just find a little way to remember that. Now, down here at the bottom, they've got some figures. And the one on the left here are showing two angles that are adjacent. And notice the little box indicating that together they equal 90 degrees. So when you see a figure like this with a right angle and that right angle is split, you can automatically see that they're complementary angles. Now, the next figure right here, these are also complements. However, they're not adjacent. And you might be given a statement that might say angle 3 plus angle 4 equals 90 degrees. Or they might even have numbers here. This one might be a 30-degree angle and a 60. Soon as you see two angles and they're not adjacent, but when you add the two angle measures, you can see that they're 90 degrees. The next one are the supplementary angles. And notice that both of these angles are sitting on a straight line. It's forming a linear pair, and we're going to see that vocab word coming up. But when they're both sitting on a line, remember, a straight line is a straight angle, and the measure is 180 degrees. So this would be an example of two supplementary adjacent angles. The next one, when they're not adjacent, again, they would probably tell you that angle 7 plus angle 8 equals 180. They might show that this is 110 and this is 70. They might give you some angle measures in there. As long as when you add those two numbers, it adds up to 180, you know that those two angles are supplementary angles. So on the next slide, we're going to practice and we're going to find the pairs. And they may not be adjacent. Everybody good on the slide? All right, one. So here's our first example. So it says, use the figure to name a pair of complementary angles. And again, they don't need to be adjacent. We just need to find the two angles that will add for complementary to be 90 degrees. So I'm going to name my angles with 3 letters. So my first angle could be BAC. And I can add that to RS. Okay, so I have angle BAC and angle RST. Now technically I could also call angle RST just angle S because it's only got one vertex there with the S. Then the two supplements, I'm looking for the two angles when I add them will give me 180 degrees. So I can see I have this 122, and when I add 58 to it, now I have a pair of supplementary angles. So I could say angle DAC along with, again, RST. And again, remember, definition of adjacent angles. These are going to be two angles that share a vertex and a side. So again, they're sitting side by side. So my pair of adjacent angles in this figure is going to be angle BAC along with angle CAD. Again, you could have reversed the letters on these, but it's this pair right here. They share that side. They're side by side. Let's try the tie into a real world example. Here is example 2, and they're tying it into sports. So when viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. They want us to find the measure of angle BCE and ECD. So here is the line that it's making with the ground, and then here is the ball return. So if you notice, they're asking us to find this angle right here and this angle right here. So again, we know that supplementary angles, when we add the two angles, they add up to be 180 degrees. So I'm going to use my angle addition postulate, and I'm going to add 4x plus 8, which is this angle here, and then I'm going to add that to the x plus 2, the other side. Set it equal to 180 degrees because I do have a pair of supplements. I'm going to add my x's. 4x plus 1x is 5x. 8 plus 2 is 10. Solve for x by subtracting 10 from both sides, and then dividing by 5. And I find out that x equals 34. Now,
why are you making it equal to 180?
Because they told me in the problem here that they were supplementary angles. So, and I know by definition that supplementary angles add up to be 180. So I'm adding, see, if you look, they're sitting on this straight line over here in the picture. So if I add this angle plus this angle, it'll be 180. Now, it did not ask me to find x. It asked me to find the measure of the two angles. So for BCE, I'm going to go ahead and plug my x into 4x plus 8. And 4 times 34 plus 8, 4 times 34 is 136, plus 8 is 144 degrees. Again, remember when we are looking to find an angle measure, we include the little degree symbol. Then to find the measure of the other angle, ECD, I know that ECD is x plus 2. So I could take my 34, add 2 to it, and the measure of that angle is 36 degrees. Now, one other way or one thing you can do to check yourself to make sure you've done it correctly, remember these two angle measures that we just calculated are supplements. So if I were to go back and add 144 plus 36, this sum should be 180. If it's not, I've done something wrong. But it worked. I did find the correct angle measures. Okay, so linear and vertical angles. We're going to use vertical angles in a linear pair a lot. And again, it's probably a nice standardized test topic that you'll see quite often. So a linear pair is two adjacent angles with no common side, whose non-common sides are opposite rays, and they're always going to form supplementary angles. Vertical angles are going to be two angles whose sides form two pairs of opposite rays. And I'm going to show you what these definitions mean. So right here is the picture of the linear pair. So again, it says two adjacent angles, so two angles that are side by side, whose non-common sides are opposite rays. So here would be the opposite rays. And then the common side is here. And notice both of the angles are sitting here on your straight line, and they're supplements. So for example, if I told you in this picture that angle 2 was 100 degrees, then you could know that angle 1, because it's a supplement, would be 80 degrees. They form a linear pair. They sit on a straight line. Vertical angles, on the other hand, they're going to be two angles. So like, for example, if I were to take angle 3 here, I'm just sort of redrawing this picture. And if I were to extend these rays and go in this direction, and then extend this one and go this direction, I've now formed a pair of vertical angles. So they're like on opposite sides of your X. If I were to add in the numbers 1 and 2 here, these would also be a vertical angle pair. Now, maybe a trick to help you remember this, think of this as like forming a V, and then down here like an A. So like a vertical angle. And even if you rotated it, you could still have a V and an A here. So these are vertical angles. So the ones where it makes the V and then the A, that would be vertical. We're going to learn later on that vertical angles are congruent. Let's try an example. Again, it's a link to algebra. So again, it's telling me that two angles form a linear pair. So let me go ahead and draw a picture of a linear pair of angles. So again, remember the two angles are going to be adjacent and they're going to be sitting on a straight line or a pair of opposite rays. It's telling me that the measure of one angle is 5 times the measure of the other. So I could say this one is X and the other one would be 5X, 5 times the other angle. Find the measure of each angle. Remember that the linear pair angles are supplements. So in order to find the measure of each angle, I would use my angle addition postulate, add the two angles, and set it equal to 180 degrees. Because my linear pair, they are supplementary angles. I'm going to add my x's, divide by 6, and my first angle is 30 degrees. The other angle is going to be 5 times 30, because it's represented as the 5x, and it's 150 degrees. So my two angle measures are 150 and 30. Another tie to algebra. Now, before we even try to tackle this problem, let's think about if I gave you a picture and I drew in a right angle box and then I drew in a ray to break this angle apart, and if I told you the measure of this angle right here was 30, and I told you the two angles were complements, how could I find this angle right here? What would I do? Beautiful. Okay, you would take, because they're complements, subtract from 90. And you can figure out that the other angle that's complementary to 30 would be 60. Everybody with me on that? So we're going to use this whole idea to answer this word problem here. So it's telling me that the measure of an angle, so I'm going to let that be represented by x, is twice the measure of its complement. So remember, to find the complement, we just did 90 minus the angle. So this is how I can set this up. The word is going to be my equal sign. So I've just written my equation by translating that into my variables and the information I know about complementary angles. So x is equal to 2 times the complement. I'm going to distribute the 2. And then I'm going to begin to solve. I'll add 2x to both sides. And I get 3x is equal to 180. Divide by 3. And x equals 60. Now I just did this problem without having a bunch of variables in it. So if I were to take my 60 to find its complement, we just saw that we would do this time, instead of 90 minus 30 to get 60, I'm now doing backwards, 90 minus 60, and the complement is 30. And if I take this information and I go back and I put it into the word problem again, so the measure of an angle, so my angle was 60, that angle is twice the measure of the complement. So the complement of 60 is 30. Is 60 double 30? Yes, it is. So it makes sense. So you could always go back and confirm and plug in the numbers that you're getting. Next, this is just like a review of the concepts. Again, remember, in geometry throughout the year, we can't assume anything about the picture except for a few things. Like we can, if we see something that looks like a straight line, we can assume it's a straight line. But if we have something that looks like an L here, we can't assume that that is a right angle. We need to see the little box, or we would need to be told that it's 90 degrees. So some things that I can conclude from this picture is I could draw a rectangle around it, and I could say that all these points are coplanar. I could also say that points A, B, and C are collinear. They're all on the same line. I could also say that point B is in between A and C. Now, I'm not saying it's the midpoint. I'm just saying it's in between. And this is where a lot of people made the mistake on the quiz, is they assumed that that question said that it was the midpoint. But it wasn't the midpoint. It was just between the 2 points. And you had to use your segment addition postulate in order to solve that question. The next thing that we can conclude is that line AC, ray BD, and ray BE all are intersecting at this point B. We can also see that we have some adjacent angles in the picture. We could see that angle DBE is right next to EBC. It's also next to ABD. We can also see that ABC is a straight angle. And we can also see that point E is inside or in the interior of DBC. So here's DBC. Point E is located inside this angle. Now, things that we can't conclude is we can't tell from this top picture that this is a right angle. We also can't say that B is the midpoint because we have no congruency marks. But as soon as the picture gets added with all these markings, then now I can conclude that ABD is a right angle. I could also conclude that B is the midpoint because I have these congruency marks here. I could also say that because I have congruency marks on the angles, that I could also conclude that BE bisects this angle because of these markings right here. So unless they have congruency marks, we can't assume anything, even though it might look like it's the exact same size. So just remember that. One more example, and then we're done with these notes. All right, so this one is saying to use the diagram to find the indicated angle measures. So for the first one, it wants me to find the measure of EFH. So EFH is located right here. Notice that these two angles are a linear pair. And I know that a linear pair are a pair of supplements. So in order to find the measure, I'm going to solve for x and then plug it back in. So I'm going to add 3x minus 6 to 2x plus 16. It's a linear pair, so they're supplements. I will combine my like terms. I end up with 5x plus 10. Move the 10. 5x equals 170. Divide by 5. Same problem I had earlier. And x equals 34. Again, it didn't ask for x. It wants the measure of this angle. So I'm now going to plug in 3x minus 6. And I'm going to replace x with 34. 3 times 34 is 102. I'll subtract 6. And that angle measure is 96 degrees. Now, if it asked for the other angle, I would do the same thing. Or I could subtract 180 minus 96. The second part, part B. This one is asking me to find the measure of ABC. Notice I've got the little box here indicating that together those form a right angle. So I know these are complements. So to find the measure of that little angle, I need to find x first. So I'm going to add the two angles, x plus 9 plus 2x, and set it equal to 90 degrees. I'm now going to add my like terms. Subtract the 9. 3x equals 81. Divide by 3. And my value of x is 27. Now, it didn't ask for x. It asked to find the measure of ABC. So ABC equaled x plus 9. So I'm going to add 27 plus 9. And the measure of that angle is 36 degrees. If I wanted to find the other one, I could double 27. So 2 times 27, and it's 54. Again, remember, if you were to go back and check, this angle plus this angle needs to add up and equal 90, and it does. So you have your homework for section 1.5. It's due tomorrow. When you come in tomorrow, again, you'll work on the 1.5 warm-up. And then after we go over the warm-up and the homework, you're going to work on your test review.